Hey guys, in this video, we're going to talk about testing your web application. Before we get started, you should know there are different types of tests that you can run against your web app. There are functional tests, which check to see, does the web app do what it's supposed to do? There are compatibility tests that check to see if the web app works across all different browsers on all different operating systems. There are performance tests. Performance tests check to see how well your web application performs under load with multiple users. Lastly, there's interface testing. How well do the different parts of your web application work together? Now you should note there are other types of tests beyond the scope of this video, such as usability and security testing. We don't ignore those, but we cover them in different areas, such as my web security class. So now that you understand there's different types of tests that you would run, we should talk about the approaches to testing. There's two main approaches. You can manually execute these tests, or you can create some sort of automated system that runs the tests for you. Obviously, manual is very simple and very commonplace. You develop a set of written tests that you go through each time you make changes to the application. You sit down and manually execute those tests yourself using a keyboard and a mouse, and you check to see if you get the expected result. You can see that this might be error prone. It might take a long time to actually execute the tests and require many people, and it might be difficult and very costly to repeat every time you want to test the application. That's why we use automated tests. Automated tests are where you develop a programmable test script that is then executed by a computer or many computers to check to see if the web application is performing the actions correctly and returning the correct result. Automated tests are easy to repeat, and you want to repeat them on demand pretty much every time you change the code in your web application. These automated tests are less likely to encounter user errors when the tests are being run, so you don't accidentally miskey a value when you're typing something into the website. And the tests can be executed quickly and potentially scaled across many computers. Now, we've talked about the types of tests and the approaches to testing. Now let's talk about some of the tools, which is the focus of this class, that can be used to execute these different types of automated tests. Let's begin by talking about unit tests. Unit tests are tests that check individual small pieces of code that you have written. For example, functions. So you've probably guessed that this is a type of functional testing. Functions can be written in just about any language. They take specific input and they produce specific, repeatable, expected output. For example, if you have a function that adds two numbers, every time you provide it the input of 1 and 2, you should get back a 3. You can create functions when you find yourself writing the same code over and over again, or when you find yourself copying, pasting your code. Now, an example of a tool for doing unit tests in a web application is PHP Unit. PHP Unit is a test framework that you would install with your web application, and you would actually write code in order to test that a particular function is working correctly. Now, if we look at the PHP Unit website and we go straight to their first steps page, you can see it's as simple as downloading a PHP archive, using Composer to bring in those PHP classes from PHP Unit, and then writing some sort of test code that is going to test the functions that you've written. In this example, they're testing an email class in PHP, and they do different assertions to say, I expect or I assert that this is the case, or I expect to get an exception in certain instances, or I assert that a value is equal. Any unit testing framework is going to allow you to define these assertions or expectations, and if they fail, will be reflected as a failed test. Now, I should point out that new unit tests should be run after making any changes to your code. In fact, anytime you create new functions, you should be creating a new unit test. You should run all the unit test functions, both new and old, every time you make changes. This allows you to make sure that something you changed today did not break something that worked yesterday. Unit tests can be automated and run every time that you add or change code in your application. For example, if you store your code in a repository such as Git on GitHub, then you can use something called a hook to run your unit tests every time changes are pushed. And if a unit test fails, then it doesn't allow you to push your changes. Now, beyond unit tests, we have application tests. Application tests check to see if the application works as the user would interact with it. It's another type of functional testing. This is where we might test to see for compatibility across different browsers and different platforms. Now, it's more challenging to run an application test because you've got all these different UI elements, such as buttons, drop-down list, JavaScript events, and so on. So what you really need is a tool that either acts as a browser or runs inside a browser. And that's where the Selenium Ide Tool comes in as an example. So let's take a look at my personal website here, thaxton.me. I've installed the Selenium IDE. The Selenium IDE allows me to record actions in the browser and play them back later, checking to see if certain assertions or expectations are met. So here's an example of recording a new test to test my thaxton.me website. You'll notice it launches a new browser and it indicates that it's currently recording what I'm doing. So if I click on a page, it records that information, and when I'm done, I give the test a name, and it shows me that it opened this window. It set the window size by default, so we could change that if we wanted. And then it shows that I clicked a link. Now, this emulates actions in the browser, but it doesn't actually test anything. So we could check to see if certain text is on the screen. So if I'd like to check to see if something exists on the page, I click in a blank row. I choose a command such as assert element present. I use this select target button to go find an element. And then when I run the test, it tells me that yes, it did indeed find that element. So this is a way to write a test that runs in a browser. It tests the application just as the user would, and it has every feature of the browser, such as JavaScript, buttons, widgets, and events. Now, the next category of testing is performance testing. Performance testing involves testing the full application, simulating multiple users on the platform. There are two types of performance testing: load testing and stress testing. Load testing checks to see how the application performs over a period of time with a normal load of users. So if you have an expectation of 1,000 concurrent users, then you would simulate what 1,000 users do at one time. A stress test, on the other hand, tests to see how it performs when a spike in usage occurs, such as when your website makes the front page of Reddit. An example of a test tool that does performance testing is Apache J-Meter. Apache J-Meter is used to test actions against the website as if a user is performing these actions. Now, I've downloaded Apache J-Meter from the Apache website, and inside the zip file, you'll find the J-Meter files, including a bin folder. Inside bin, or binary, you'll find several different ways to actually execute J-Meter. If you're on a Unix environment, you can run jmeter.sh. If you're on Windows, you can run jmeter.bat. This window will pop up. And after a moment, the J-Meter application will appear. Inside of J-Meter, we use the idea of a test plan to create interactions with our website and to check, very similar to how Selenium IDE checked, for particular things to be inside the web page. We can also check for things like response codes and so on. The most important part of J-Meter is that we can create within our test plan multiple threads where we run these tests as a number of users. So instead of just having one test run, we can have 100 users run all at one time. This allows us to simulate either load or stress tests against our web application. Lastly, we have another type of test called interface testing, where we test different parts of the application and how they work with each other. Traditionally, this was focused on the web server to database connection. So you'd typically have your web server running on one computer and your database on another computer, and we would test that interface between the two. Nowadays, we're more focused on web APIs. Web APIs are very similar to functions in that they take a very defined set of inputs and produce an expected repeatable set of outputs. So for example, if you have a web API that adds numbers, if you provide it 1 and 2, it should return you back 3 no matter what. The difference is a web API works across a network when you call that function. Now we may need to test our own APIs that we've written. For example, if we create an API to our database, or we may be using someone else's API, which we have absolutely no control over other than knowing what our inputs and outputs should look like. In any case, we need automated test tools to test these interfaces. One test tool for testing APIs is Postman. Postman is an API test tool that works similarly to Selenium or J-Meter in that you define certain tests that you would like to run, and the Postman application will execute those tests, will check for the results, and will tell you if they succeeded or failed. Now, the Postman interface looks something like this. We enter in a URL to a resource. We enter in the type of request we're making, a GET or a POST, for example. We define any parameters we might want to include, any header values we might want to pass in, and we send the request. It tells us that we got back a response from the website. It shows us the cookies we received, any header values we got, and it shows us test results. The test results are little scripts that we create that check for certain conditions, much the same as we did in Selenium IDE. In this case, Postman has an example of how to check the response code. We could have checked for things like the response body containing a string. So I'll click that, add it in, and what we have to do is tell it what string to look for. If we go to thaxton.me, I could copy a specific string right off the website, paste that right in here, run the test, and you'll see that it passed both the status code 200 test and that the body contained the string Thaxton.me. You should note that Postman is positioning itself not only as a test tool, but as a tool for designing and documenting your web APIs. Now, to recap, we've gone over unit testing with PHP unit, which is a form of functional testing. We've gone over application testing with Selenium, another form of functional testing. We've looked at performance testing with J-Meter, and we've looked at interface testing with Postman.